technologies like AI is really going to disrupt every industry, and manufacturing and industrials is not going to be left behind. So thanks all for attending. It's going to be a really power-packed session. There's a lot of new content that we've put together, and looking forward to sharing this with you in the next 60 to 90 minutes. So before I get started, what's going to be covered in this webinar? We're going to be talking about a little bit of basics of what is machine vision and what's happening in the last couple of years. And it's not just average revenue per employee. We've also realized that with COVID and other things, the dependence on human is a risk factor. So the more you're dependent on humans, manual operations, there's a risk, because if you have lockdowns and the people can't come to work for you, then the dependency is high, and so you're impacted in the operations side. So you want to reduce that dependency as well, and that's probably why we're seeing a lot of interest and in automation. But when you look at automation in a shop floor, in a manufacturing environment, there's really two different areas or operations that happen. One is that people are using their hands and their legs. So it's basically their motor skills. What are they doing? They're moving things within assembly lines, between stations within assembly lines, or they're really assembling things themselves. So they're putting things together, assembling maybe cell phones or automotive parts, whatever. Now, the other function in the operator is inspection. They're looking at things. They're looking at things and deciding, okay, is there some quality defect? Is there, has it been assembled correctly? So when you need to automate these two functions, there's really two different ways to automate. The first one is with robotics and material handling automation, right? Machine building, special purpose machines, or assembly machines, packaging machines, filling machines. So those are the things that automate the motor skills. The second, and of course, robots, right? Robotics is picking up this huge exponential growth in terms of robotic deployment in factories. But robots, are just moving things. They're moving, lifting things, moving things. But what is replacing or automating the inspection operation is machine vision. And so that's why, if you look at these two aspects, machine vision is really a very key component to automating or reducing the dependence on humans and driving up productivity, etc. So that's why machine vision is gaining a lot of popularity. It's important, and why there's a lot of interest. But it's also not as widely adopted. And there's a couple of reasons for that. It's mainly because I think the technology has to mature. It is a little complex in terms of how to. It's not easy. Lifting something, you can easily train a robot, but then to replace the human brains is not that easy, right? You're replacing something which a human is looking at. It's going to be a lot more complex than just lifting something and placing it on a conveyor. And that's the reason why it's not been adapted as aggressively. But that's changing today because of technologies like AI and deep learning. This is becoming more of a possibility. You have systems that are as intelligent as the humans are, and it's easy to train and replace the human cognitive functions. And that's why today it's, like I said, never a better time to look at technologies like machine vision and deep learning for this. So I'm glad you're attending this. Super excited to be taking you through some of the aspects of vision and deep learning. So before we get started, I just want to take a quick poll, understand, who is, which industry you're representing. So, you should see a poll in front of you. If you can take a minute to, give us your feedback on, which sector you belong to. Are you in manufacturing? Are you doing system integration? Are you in machine building or others, right? Or are you in student academia or consulting? So if you see the poll in front of you, please respond. It takes a few seconds, and it'll be good to know, what your background is. Okay, so about majority of you from manufacturing. Okay, so that's good. That's it's going to cover most of this is going to be manufacturing specific. Few of you in systems and integration. Okay, fantastic. Machine building. Okay, and okay, a few students, consultants, and others. Yeah. Okay, great. And all right. So academy and consulting is overtaken. So most of you are either students, manufacturing, or system integration. Great. Okay. Wonderful. So I've just put this up. So great. This is going to be, quite interesting for all of you. So this is so let's move on, right? So now, if so, let's what is machine vision? So let's define what is machine vision. So machine vision is really the process of acquiring digital images and computing a result to automate an industrial process. So it's processing, it's software, right? So when you say processing, it typically means process, image processing, and it's processing digital images, right? And why do you do that? It's to automate something. It's automate an industrial process, and that's really what machine vision is about. So if you were to put it in pictures, you have this person looking at manually looking at something and identifying if something has a defect or not. And if you want to replace that, basically it looks like this. You have a camera, it's looking at the same object, and there's a software that's processing that image captured from the camera and arriving at the same judgment that this human on the left hand side is arriving at, the same judgment. So this system here is doing the same job as the system here. So you eliminate the human. Yeah. So that's machine vision. So what are the benefits? So when you talk about it, so cameras, you don't need to touch the object, huge benefit, non-contact. So it becomes very easy to integrate. It's very easy to put a camera pretty much anywhere on the assembly line, right? You don't need to disrupt your production line, you don't need to disrupt or change your any production flow. The speed, software is really fast, it's consistent and accurate. So number of benefits. But how can you use these benefits for a business outcome? What advantage can you derive with this technology? The biggest advantage or the outcome that you can drive is manpower reduction. So you're reducing your dependence on humans. So a large part of quality control today is being done with human workforce. You have to train the humans, you have to bring them in, they're inconsistent. So if there's anything specialized, you have to provide a lot of specialized training to inspect something. And if you lose a person, you have to retrain a replacement. So there's all kinds of logistics, and it's not just the cost in terms of manpower, it's the inconsistency and the challenges, the logistic and practical challenges in dealing with humans in your factory floor, that is the bigger pain that we come with. So reducing that dependence is always an added advantage that people are trying to get as an outcome. And of course, more importantly, it's consistent product quality assurance and control. So it's not subjective. So if you ask two humans for an opinion about something, you may get two different results. But it's not the same with the software. So every time you present a specific image to the software, you're going to get a consistent result. So it's that consistency is what you can derive as a secondary benefit. And then also you have traceability, because now everything is digitized in images. You can store your images, and later you can recall those images. And then if you need to really validate that, okay, this was inspected and this is how the image looks like, you have traceability. So that indeed there's proof of inspection. Whereas if you're dependent on humans, the human will say, yes, I've checked 100 parts and everything was look good. But how do you actually validate that indeed the check for all those 100 parts were checked correctly and the right outcome was derived? So that's going to be the main the three main benefits that you see, right? So what is the different kinds of applications that we see in machine vision, using machine vision in a factory line. So I'm going to go through this a little bit quick. I won't spend too much time. But the first kind of application is called object detection. So this is an example of a refrigerator, and you want to identify or detect objects that are within that refrigerator. And the objects may be shelves. It could be the presence of a manual. It could be the presence of the ice tray, right? The ice cube tray. So you want to make sure all those objects are present, and you can use machine vision to detect these objects, and that's why it's called object detection, right? The other key application of machine vision is measurement. So measurement is nothing but measuring physical dimensions. You know, Instead of using a scale, you can use a camera and a software and can measure a dimensional property. So in this particular case, let's say you want to measure the thickness of this beading. This is actually a rubber beading, and you can use machine vision to measure the thickness to control the quality, so to make sure the thickness is always consistent. A third example is flaw detection. Flaw detection, like cosmetic defects, scratches, anomalies, paint defects. So a number of such applications can be detected and identified using machine vision. Print defect detection, yeah. So there's a lot of printing and packaging, especially. You could, variable data printing using inkjet printers and labels, or it could be packaging, rotographic, flexographic printing. So all those are done in high speeds. There's a very, multiple artworks are, dynamically changing, and it could, because of some physical anomalies, the print can get missed out. They can have tiny miss outs, or it could have discoloration. So that can also be detected using machine vision. Another common example is 2D code reading. So reading barcodes. So with 2D codes, you need to use an imager, a machine vision, or a camera-based reading. So that's a common application as well. Reading characters, human readable characters, or optical character recognition. So you printed something and you want to read that and then verify that print or pass that print on to a downstream system. That's another common application. You can use machine vision for that. And then another kind of application is classification. Classification is where you're classifying or bucketizing or categorizing different the image into certain categories or classes. So an example is SKU identification. So you have different bearing SKUs, and by taking an image, you want to immediately identify which SKU it belongs to. So product mix up, sorting, those kind of applications you can use classification type of for an application. Classification as an application can be implemented using machine vision. The last one, which is gaining popularity, especially with the adoption of robots, is robotic guidance. And that application, is what we call locating. So you have cameras that are locating objects. So, remember I talked about object detection, which is detecting the presence of an object. But if you actually now not only detect the presence, but also detect the location, compute the location, like the physical location. So it's a combination of object detection and measurement. Then you have identified the physical location, like the coordinate system, and then you can pass those coordinates to a robot, which can then pick that part. So a robot is blind by itself, right? It only has arms. So when you have a camera which is guiding the robot using vision, then you're making that robot more human-like. So locating is a very key aspect of vision-guided robotics. And that's another common application of machine vision, which is immensely popular. So, so those are the main sort of applications of machine vision. Right now, let me stop here and also take maybe any questions that you may have, and I'd also like to understand your familiarity with machine vision. So a number of you said you are from manufacturing student academia, and I want to understand if you could just give me your feedback on the second poll. what is your familiarity with machine vision, right? So basically, have you used machine vision? That means you're really familiar with it. You've seen it but not used. So basically, you've seen videos, or you may have seen a vision system which is being used in a different factory, or you've heard of this but never even seen it or used, but you've heard of it somewhere, right? So then select option 3. And option 4 is you have no idea about what machine vision is. This is the first time you've heard about machine vision. So please give me a feedback. Let me. Okay, so number of you have used machine vision. That's good. So it's getting popular. So have seen but haven't used. Okay, and about 30% of you have heard but not seen or used. Okay, but nobody is in the fourth category of no idea. So you've at least heard of it. Okay, great, fantastic. So this is good a session for you, because we're going to go into a little bit of a deep. This is not a very basic session, so we're going to see a little bit more in depth about machine vision. Okay, thank you. So so a number of you who've used machine vision and have seen, this may actually be let's look at the different parts of a machine vision now. So when you think of machine vision, your thought is first cameras, right, or software. But there's really 3 different distinct parts. It's not just cameras or software. It's a total system. The vision is a system, and it needs to work in coordination with other things which are in your factory floor. And so that's why it's important to see it as a holistic view. And the 3 parts really that go into this system is, firstly, the material handling, right? Now, in order to make sure that you are consistently acquiring images, that the camera is able to take parts consistently, images of those parts consistently, you need to have material handling in place. If all your material is dumped into a bin, you really can't use machine vision that effectively, because those are parts, they're oriented differently, they're hidden in different layers, a bunch of parts just in one bucket, right? Not really useful. So you need to have something that is separating the parts, localizing it, moving on a conveyor. Some kind of material handling needs to be there. That's the first basic requirement for a machine vision system to be in place. The second element is the image acquisition. Image acquisition is is just acquiring images. It's not processing, it's not doing software, it is cameras. Now camera is one element, but there's so many more elements to this image acquisition. But that's the second element. And the third element is the image processing. The image processing is software, right? So first you move the material, then you take pictures of the part, of whatever you want to inspect. And once you take the picture, you're applying software on top of that images to identify what is the what do you call to identify a result or a judgment. So just a few questions. Expand MV system. MV system, machine vision, Mr. Rao. It's just short form. MV is machine vision, right? So what are the different parts? Okay. Yeah, Mr. Bishwadeep, you just joined. Welcome. We're just getting started. And we also have, this is going to be recorded, and the recording is going to be shared with you afterwards. So in case you've missed a few things, you can always go back and record it. So, but welcome, glad you could join us. All right. So so we talked about the different parts. Now let's just go a little bit. Material handling automation, as I mentioned, what is the physical automation, material automation required to help with image acquisition? So it could be a conveyor, it could be a pick and place system, it could be manual, right? You can take things manually and place it in front of a camera. That's also material handling, right? Although not very fast or high speed, it still is material handling. And then it could be robotic, right? So the second part of the machine vision system is image acquisition. Image acquisition is basically, again, different components of image acquisition systems, which is the trigger. The trigger is nothing but a signal to the camera to take the picture, right? Now, you've all taken selfies. You got to press a button, right? That's a trigger. It's the same thing. You have a camera, it's sitting in front of an assembly line, parts are moving. What's the trigger? You don't want to, it obviously can't be manual. You can't go and click pictures every time a part comes. You want to have some automated way of doing it. And typically you have like a photoelectric sensor or, some sensing or a PLC signal that, tells the camera to take an image. The next part of the image acquisition is the camera itself, right? There's an industrial camera typically. Now you want to go with industrial cameras, not consumer cameras, web cameras, etc. Mainly because it needs to be running 24/7. It needs to be rugged. It also needs, more control, programmatic control to change certain parameters in the camera hardware. So specialized industrial cameras are available, which you can use. And of course, you have to use the right optics. Optics is nothing but the lens. And there's a number of webinars we've done which goes deep into this image acquisition system, how to pair optics with the right cameras, what are the common mistakes that people do in selecting optics. So, go through our website, go through our YouTube channel. I cover this in a lot of details, which, is, if you're looking at, as a practitioner's approach to machine vision, this is very important for you to understand. The last part is illumination. Illumination is lighting. So you want to make sure that there's consistent lighting because, sometimes you're operating, we are today in a day of age where manufacturing is happening 24/7, 3 shifts, there's day, there's night, right? And you want to be as consistent as possible. Something that works well in the daytime, in the nighttime, because of artificial lighting or tube lighting or overhead lighting, you don't want the camera to start taking images which look very different. So the way to counter any kind of ambient lighting variation is to have your own illumination. And the type of illumination is going to be very critical in making sure that the right consistent images are being captured. So this is probably one of the most critical aspects, which is mostly overlooked, but I would say very, very important in making sure that you're getting consistent image acquisition. So those are basically the types of the parts of an image acquisition system. So, this topic itself, I could talk about, image acquisition in depth for about 3 hours and still not cover even 20% of, image acquisition. So, just as an example, now just camera selections. There's so much of different parameters in terms of what camera type, what is the interface, the communication interface, the resolution, how to select the right resolution, what is resolution, the frame rate, the shutter speed, shutter type, this global rolling, the sensor size, within the imaging area, quantum efficiency. So there are a number of these parameters, and it's not just resolution. You may be only familiar with resolution, but there's more to resolution, more to camera selection than just resolution. But I'm not going to cover too much depth in terms of image acquisition because today's topic is deep learning and AI, and that's mostly in the image processing. Okay, so that's the third part. The third part, we covered material handling, image acquisition, and image processing. So now you've done all this. You've got the material flowing in the right way. It's localized, it's moving in a conveyor, or you've got a robot that's picking and placing it. You've got a camera which is taking beautiful pictures or clear pictures of the object, and now you want to do the processing. The third part is the image processing, and so here is where there's a lot of exciting development that's happened more recently in software thanks to technologies like AI, right? Now, how many of you have really heard of or are familiar with AI or artificial intelligence in the context of machine vision, right? How many of you even know what is AI? You may have heard of it, but you know what is AI? If you know what is AI, type out me in the chat window. You know what is AI, artificial intelligence. If you have no idea, type out no, N-O. No idea, right? Okay. So a mix. So what is AI and what is non-AI rule-based, right? So there's really two software approaches, which is you know um, uh, sort of approach to processing, image processing. So remember, we're talking about image processing. There's rule-based and there's machine learning. And machine learning, AI, all that, there's a number of terminologies that has been clubbed together, which may be confusing. Let me cover that, right? So what is rule-based? What is machine learning? Now, before I go into machine learning, let's also, acknowledge that there's different terminologies. There's AI, artificial intelligence. Then there's machine learning, and there's deep learning, right? Now, how many of you have heard of deep learning? Please type out DL if you've heard of deep learning in the chat window, right? It's a very advanced version of machine learning. So yeah, a lot of you have heard of deep learning. So that's good. Now, AI is basically the overall superset of this whole science to software. Now, and that's been around since the 50s. Now, in the 1980s, this whole concept of machine learning started to come in. AI is basically intelligence that you're replicating, human intelligence which you're replicating into a machine. Machine learning is a learning process of how this a system becomes intelligence. So there's a lot of science, research, etc., that came into existence in about the 80s, which taught machines to learn. What are the different ways to teach machines? But it wasn't until more recently, that 10 years ago, that a very advanced form of machine learning called deep learning came about. Now, deep learning is really a very machine learning on steroids, like powered machine learning, which made it possible to learn complex tasks like speech, for instance, speech recognition. So if you wanted to have a system really understand what you're saying when you talk to Google or Siri or Microsoft Cortana, right? The system is really understanding, and it's text to speech, or speech to text has become so powerful and accurate. When you say, "Hey Google" or Alexa, right? It really understands you so well, and that's all thanks to deep learning, advanced form of machine learning called deep learning. And the same thing can be applied to images as well. And you can have human levels of intelligence being programmed for machines to do. And that's deep learning. So let's go back to rule-based versus machine learning. Right. So I just wanted to break down what is AI, what is machine learning, what is deep learning. Just there's some minute differences between those terminologies. But really the difference between rule-based and machine learning is the approach to training, how you teach a system to learn. And in a rule-based system, the rules are defined by the programmer. Now, in other words, you have to program and teach the system that, okay, this is how you perform a task. And you have to, it's a programmatically driven approach to learning. Whereas in a machine learning based approach, the machine is learning the rules, or it's coming up with the rules. And as um, as a programmer, all you're giving is examples, and the system is learning from those examples. So it's a lot easier. So it's more human-like, right? When you want to teach a human, the best way is to teach with examples. And you allow the natural intelligence of the human to figure out, okay, the learning happens on its own. The human itself is learning. You're not really programming your brain. You're giving examples, and your brain is trying to process those examples and figuring out, the information with those examples. And that's the fundamental difference between rule-based and machine learning-based. So let's take a couple of examples. Let's take this specific example that you're trying to teach a system to identify the wheel variant. There's 8 different variants. They all look different, right? Can you see the difference with the different wheels? They're all different. None of them are the same. They may be very similar, but they're not the same. And you want to teach a system to say, when I give you an image of a particular wheel variant, you need to tell me which of the 8 variants it belongs to, right? So that's the objective. Now, in the rule-based approach, you have to then deconstruct this. You have to reverse engineer this problem. And then you say, okay, let me see. Now, here there's different wheels. One fundamental difference that I see is the color, right? One is silver, one is black. Maybe I can use some kind of a programmatic rule that says if the average pixel shade is beyond a certain threshold, it's closer to the black region, then it becomes one variant. Otherwise, it's the other variant, right? So you can use a color uh, as a rule. But then, just color is not sufficient. That may separate out maybe 50%. You can from you can identify 50% of the variants of the 8, but you can't really. How do you further distinguish? Like, for instance, you have these holes, right? Now all these are black, all these examples, but maybe the number of holes that are present is another rule that you can apply, right? So you see what's happening here. You as a programmer are deconstructing, you're reverse engineering this, and you're looking at these examples and then trying to figure out, how do I make the system learn? And you need to then write programmatic code to say, okay, let me put a color filter, let me put a hole detection algorithm. And then what if it doesn't have holes? You need to really use maybe spokes, right? It becomes complex. So instead of using this sort of approach, what if you just give it examples and you let the system figure it out? Wouldn't that be a lot simpler, right? And that's really the fundamental difference between rule-based and machine learning-based. And so when we talk about machine learning-based or AI-based machine vision systems, it's really that. It's giving examples and you're allowing your system to learn on its own. And the learning output is then used for prediction in your assembly lines. So let's break this down in terms of what is the process. How do you actually go about building a system, an AI-based machine vision system? And so the process is 6 folds, right? So, and we covered 3 of these already, 2 of these, right? We talked about the pre-process automation, right? Material handling automation. First parts have to come in front of the camera and all the assembly line automation, etc. The second is image acquisition. We talked about that as well. Now, once you've acquired all those images, right? The third step for an AI-based machine vision approach is data preparation. So remember, I told you the teaching process is example-based. So you need to get enough examples to teach, because if you just give it one, that's not good enough. You need to give it a variety of examples to allow a comprehensive teaching, right? And that step is called data preparation. The next step is then training, and that's the machine learning training. So you're teaching the system with those examples how to predict this in the future. Now you give it enough examples, the system becomes intelligence, then you deploy it, and then now it's intelligent enough to be able to do this on your assembly line. And when it's doing that prediction, it's called inferencing. So it's called deep learning inferencing. So there's deep learning training and there's deep learning inferencing, 2 distinct steps, right? Now, these 2 steps are not really, siloed in the sense that once you're done with training, then you can move to inferencing and you're done. It's a little bit iterative. So you do the inferencing and then you may have to retrain, because it's a continuous learning process. So it's like, it happens a couple of times before you actually get this to the level of accuracy that you require, right? So, and the last process is the post-process automation. So again, material handling. You want to reject something. So that's material handling. So let's cover these 3 steps, which are, mostly the deep learning or AI-based steps. There's 3 steps. There's data preparation, there's machine learning and training, and there's inferencing. So let's cover that in more detail, right? So the first step is data preparation. So imagine you have the assembly line, you have cameras, you've collected a lot of data. Now, what do you do with that data? Data is nothing but images. You have something called, data preparation, which is, where you have to annotate. So you have to give it some clues. You have to give the system some clues as to what to learn. So let me actually give you a live example. So we have a system which so let's take an example. You have this, now it's dinner time, I know, 7 o'clock. All of you must be feeling hungry. So I'm sharing pictures of yummy pizzas. Bear with me. But so let's assume that you have, you want to train a machine vision system to detect how many toppings are there. This is, this tomato slices, pepperoni slices, right? You want to detect how many there are. It's an object detection problem. Now you've taken enough images, right? So I've captured so many images, right? Sample images. You can see on the left, all these images are captured. They're all different. Each one, some half pizzas, quarter pizzas, full pizzas, right? 3/4. So all these different various examples. Now, from this, is it sufficient for the system to then know that, okay, you want to detect this pepperoni slice just from the images? No, right? You need to give it some examples. You have to say, hey, remember, the system is dumb. You know what is a pepperoni because you've seen these examples, but the system hasn't. So you have to do something called annotation. So what you do is basically you have to go. Let me do one and delete this. I have to go in here. I'm going slow so you can see it. So I draw a box around this, right? And after I draw a box, I select what is the type of topping this is. Either, there are different toppings. They could be pepperoni, or they could be jalapeno, it could be capsicum, right? In this case, I'm going to select P for pepperoni, right? And move on to the next. So like that, if I draw enough boxes, it, with enough examples, that is sufficient. You don't need to really sit and, give different rules and programs and write. Oh, zoomed out a little bit too much. Right? And that's really, isn't it a lot more simpler than writing programmatic rules to identify, okay, what is a pepperoni, what is a jalapeno, color, shade, those kind of things. So you just draw boxes. And then you can also do verification. All this is data preparation. So for instance, here you want to make sure that all your, these are jalapeno slices. So here you can see that, there was something that was mislabeled, a pepperoni. So you can say, required correction. So this was mislabeled. So you don't want to confuse the system. So you can check, and for everything else, jalapeno, it looks okay. So this is the process. This is data preparation, right? So here you're making sure that you're tagging all the pepperoni slices using bounding boxes. You're labeling it correctly, and you're making sure that the labels are added correctly. So once you do that, then you're ready for the next step, which is machine learning training, right? And in training, you select different what you can, you have different training parameters. You select deep learning models. And this is, our EagleEye Cloud software, by the way. This is an application that is being developed by Qualitas to do this, advanced deep learning training. It's all browser based. It's on the browser. You don't need any specialized hardware, and it can be done just using a Chrome browser and logging into our application. So let me go back to the presentation. So I hope you got an idea. I wanted to show you a practical demonstration of what is data preparation, what it means. It's not rocket science. All you need to take those images, draw some boxes, and then say this is, jalapenos, this is pepperoni. So let's say you're looking for, the wheel variant, that example. So all you needed to say was this was variant 1, this was variant 2. You needed to tag it, all the 8 variants. So if you have enough images of variant 1, you tell the system that this is variant 1. Then you give it enough examples of variant 2, and then you tell the system it's variant 2. And then you go through something called a training process. And the training process is where the system learns how to identify this on its own. So basically, you give enough examples, right? So I said you give it training data. So you feed this into the system, and the system is then using a closed loop algorithm to check. You gave it enough examples, then it tries to predict. Then it evaluates whether it's predicted it wrong or right, because it knows, right? You're giving it the image as well as the tag. You're telling it that this is variant 1. It's not a blind training. So then, it evaluates on its own, and then it says, okay, did I get it right? If it got it right, then it gives, the weights are adjusted. This neural network is basically a network of weights. And so, not to go too deep or complicate this concept, it learns, right, by way of building a model. The model is nothing but a network of weights, which is then used for the next step in the process called inferencing, right? So there's data preparation, training, and then inferencing. Now, inferencing is nothing but it takes an image and then it breaks it down, and then it runs this computation, and then it decides, okay, which of the 8 variants it is, right? And this is a much faster system compared to training, because training, it goes through multiple iterations to learn, right? So once again, what is the difference between training and inferencing? In training, you are using a closed loop system. So let's say you identify a person versus a bicycle versus a strawberry. So you give it lots of labeled data, and then it builds this weight file, and then it checks, okay, has it got it right or wrong? And then it does a back propagation, and it does, this tuning of these weights. So it's an 8 hour, 10 hours. It takes a long time to do this training and learning when you have those images. Once the images are being trained, then you can do this inferencing. So you just give it an image, but it's blind. You don't know what the label is. And then it identifies whether it's a bicycle, a person, or a strawberry, just an example. That's the inferencing part. So there's another difference in terms of the computation, whether, for inferencing, you can use low power devices. You can use just a PC. It's very simple. It doesn't require much. But the training requires, complicated high intensity compute. And the compute is where, because it is an intensive process, you require specialized hardware. And now, in order to avoid using expensive hardware, now the cloud has become a very real and practical aspect of how people are moving to the cloud for training. And we've also, what I showed you today a little earlier with the Qualitas EagleEye Cloud, we use the cloud as well. And there's a number of advantages. It's basically inexpensive. You're paying only for usage. You're renting out the cloud compute space. You can use like Amazon Web Services, Microsoft Azure, Google Cloud Platform. There are a number of those and many more. It's elastic. Elastic being, you can use 10 machines when you need, use one machine, right? It can, scale. scale up and down very easily, and you pay only for what you're using. And there's operational simplicity. You don't need to really maintain these expensive training devices on your system. So all the maintenance is handled by these service providers. So cloud has become a very, very powerful tool and infrastructure that you can use for your machine vision training. Now, okay, so let me. So one more important aspect, about rule-based and AI-based. Not everything can be AI, right? Now, the simplest way to judge whether is an application AI friendly or not is to ask the question whether is only a human eye and mind able to do the job without using tools, external tools, right? It's just, can you look at something and come up with a decision, right? If the answer is yes, then it's a great fit for AI. If the answer is no, you need some tool or you need some instrument, then it's not just the human eye, it's the instrument also that is doing this application, or it's providing some input to that judgment. And so AI is not really is a good use of this candidate application. So let's take a look at an example, right? So can you tell me if this is suitable for AI or not? So let me play this video. So just see what the human is doing. So whatever he's doing today, do you think it's suitable or not suitable? If it's suitable, say yes. If it's not suitable, say no. Can this operation the human did, can that be, okay. So it's yes, exactly, right? So you're just using human eyes and mind. There's no other tools. He just saw it and he made a note of this. He made a decision. Let's take another example. How about this? See what he's doing? He's measuring something. So is this suitable for AI? So probably like 100 microns, right? So can you replace the calipers with AI? The answer is no, it's not suitable for AI, because this is more of a rule-based application, because it's not just a human mind. You're using a tool like a vernier, right? So a machine learning, you cannot give it enough examples and say, now learn how to measure. Because can the human really look at a part and then do the job of a vernier? Not really, right? Human mind cannot do the job of a vernier calipers or a scale. So, and that's probably the distinction. So a lot of people get confused, oh, this can be done with AI, this cannot be done with AI. But it's really simple. If only a human eye and mind is applied, that's a candidate for an AI-based system. Okay, so with that, so yes, additional automation, Viswajit is saying, but additional automation can be done with vernier. Yes, that's right. But you can do automation, but it's not AI. You cannot replace AI to do the job that a vernier is doing. That is my point, right? So, so before I stop, any questions? Now I'd like to spend the next 5 to 10 minutes for system integrators. So for those of you who are system integrators, now there's a very exciting opportunity that we are providing as part of Aqualitas. And it's how you can take this amazing technology, machine vision AI, and we've developed a partnership program for system integrators to offer you the tools and the necessary support to start developing machine vision based, AI based machine vision solutions for your customers. So we want to work with you in partnership. We've got the technology, we've developed a lot of processes, systems, technology, etc., and we believe we can partner with you to jointly go to market with companies that require machine vision based automation. So any questions before I move into that? Any questions I can take? Okay, so let me talk about the Qualitas Preferred Partner Program real quick. And it's as you know, as I've mentioned, Qualitas, we're now 13 years old. We've been working in the visual inspection field for a number of years. We've got over 150 production inspection systems. So we've got a lot of experience, a ton of experience in terms of how to develop production level inspection solutions. And today, Qualitas deployments are inspecting about 12,000 to 15,000 parts per hour as we speak, right? And we have offices in Bangalore in India, right? Of course, we are successful because of our partnerships. We are partners of the NASCOM, Intel, NVIDIA, HP, Azure, Amazon. We are the winner of the AI challenge last year, 2020, where Accenture and this was run by CII, Confederation of Industries of India, and we won it for the large-scale deployment of AI in industrial environments. And we've won that because of a product called EagleEye. Right? The EagleEye is a new paradigm for visual inspection. So it makes using AI-based machine vision very, very simple and very integrator friendly. So you don't need complex training investments, etc., to start using machine vision using AI systems, right? So it's a 7-step process. You have the camera. It's an end-to-end system. So let me show this in action, right? So how this works. So if you look at, this is a recent deployment that we did in why is the video not playing? Okay, something wrong with the video, but it's basically, a line that we did. You have cameras that are taking pictures of identifying, defects in an FMCG packaging line. And what we were able to do is automate this in 4 weeks, right? Very quickly. And using very simple integration, lean integration technology. So this is what we want to offer to our partners, right? And the partner qualification and the process is very simple. So we have a simple partner evaluation to make sure that we are, the right partnership for us. And we just want to understand a little bit about your background, what your customer base is, what's your current deployment capabilities, infrastructure, etc. Then we have a signed partner agreement, an MOU that we sign. Then we ask you to procure some demo equipment for you to be able to demonstrate things to customers. And then we give you a ton of training, right? We train you with image acquisition. We train you with requirement analysis. We train you about machine vision and AI. So your staff is trained up. And the biggest benefits you get is, we give you qualified leads. So we do a number of events, marketing, seminars, webinars. We're very active on social media, digital marketing. And so we have a ton of inquiries that are coming up, and we can't cater to it on our own. So this is why we need partners. So we give you qualified leads. You don't need to spend on marketing. And then we give you specialized and exclusive training on machine vision, deep learning, and AI. We give you discounted hardware and technical support. We give you access to all the templates documentation. So it's basically plug and play ready, right, for you to start developing cutting edge applications using machine vision and AI. And of course, there's discounted subscription to the Qualitas EagleEye Cloud. and there's discounted inferencing software. So there's tons and tons, and lakhs of benefit of partnering with us, so that we can jointly go and automate a number of visual inspection process. So eligibility criteria, we require 4 years of experience in machine system integration, machine building. No prior experience required in machine vision or AI or any of that stuff. Just system integration, machine building, control system knowledge, maybe motion control, PLC programming. You must have done at least 5 material handling projects and have about 10 full-time engineers or technicians, right? That's the eligibility criteria. So if any of this sounds interesting, you want to partner with us, please send us an email, cs@qualitastech.com, and we'd love to discuss how we can partner together and take advantage of this wonderful and exciting technology of machine vision and AI. It can really boost up your business, right? It can do wonders. And we are going to be here with you every step of the way. We're going to be your partners in this, right? So we're not selling you things. We literally mean it when we say we want to partner with you. And with that, I'm going to wrap up. Thank you so much again. And I hope it was useful for you. I really enjoyed the session, and love to be in touch, especially again, integrators, machine builders. If you are interested in how you can use machine vision to really unlock some massive value, get very competitive with what we are offering, get in touch with us, see if we can partner together, and love to hear from you, if we can help you with any machine vision requirements. With that, I'll wrap up. Thank you so much.